So we looked at what people will normally refer to as the traditional machine learning algorithms like decision tree, random forest, and they all have their use cases and their usefulness even in today's machine learning model development for AI stuff. However, we felt the need that most of these things that decision tree can do, random forestry, the classifier, support vector machine, and all the other ones can also be done through using neural networks. So our emphasis over the years have been on neural networks. This particular year, we decided to review our material and also add this. So we dealt with this, then we came to some regression algorithms, some linear regression models, and all these ones. Then we came to the deep neural networks, where we were building on the knowledge or the foundation we've had on the shallow neural network and also on the perceptron. So we saw how deep neural networks were. It's just in most cases a matter of increasing the number of hidden layers as far as your network architecture is concerned. So we looked at that and we went to a situation where we're deploying some of these models that we built onto web applications. And for this year, once again, we did a review and we saw that, okay, last year we did a little bit of Django and then with Flask, but that's a whole lesson altogether. And like I did indicate, let me just show you and also share the link with you that on my personal YouTube channel, or what I'll say, the commercial YouTube channel, there is, I've done some work in that regard, which is a little bit different from what we have done. So I believe this one will give you a different perspective on how some of these things are done. So what I'll do is I'll share the link to this video so that for those of you who want to extend your knowledge on some of these things, you can have access to. Except that when you use Django, the framework is a little bit big. So that's like you being heavy on software development. Okay, but our emphasis was on the machine learning model development. So we were not too heavy on the web application stuff, even though we use Streamlit. So with Streamlit, and in fact, the problems we had the last time, I've resolved them. So we're actually going to complete that process of building that model so that per the engagement I've had with Dr. Mills, you are supposed to also explore, get some data from the various sources that we explained or we showed you there. I mean, from Kaggle, from the UCI machine learning repository, and other places that you may find data to also test your skill, develop some models, and also try deploying them one way or the other. Now, one of the things I found quite recently was I was looking at the Ghana Statistical Service, okay, and they have actually a data set, okay, or a database. I know they are the government agency, so they have some data they've collected, okay, a lot of which are, I'll say, I mean, local data, okay. What's happening? Please. Oh. So the last time, I didn't have a lot of time, but then I was just trying to go through. Oh, is your website hacked or something? Because this redirecting and going back to other pages, oh, wow, it's looking a little bit funny over here. But let's see if we can. Yeah, so they have the data, okay, and with some of the data that they have, we can actually leverage on that resource and also look at some problems or do some analysis of the data, do some visualization of it, and then build a model to, for instance, maybe predict the population in the next 10 years. And these are things that will bring a lot of attention to some of the things that you are doing. So you can just go there and also check out on the data set that they have and what you can actually do with the data. I was actually thinking about a problem this way. So I was looking at an instance where we know every 10 years they do a population census. So I was looking at, okay, let me pick some data I could get from, let's say, I think the last census was in 2020 or 20, no, okay, there was COVID 2020. So I think they did, or that census was done in 2021. But before then, 2010, there was a census. So I was actually thinking about this. I'm going to pick a data or from the data they collected from 2010, do a prediction into maybe the next 10 years. And then now compare the predicted values that I have based on maybe some metrics. Okay, I'll just brainstorming and thinking about this. And I'll compare it with the actual data we've had from the actual census that was conducted in 2024. Sorry, in 2021. Okay, that 10-year gap. Then depending on the variations of the figures, okay, I'll be able to make some analysis. And indeed, if they are very close, then we can, based on that model and some inputs from the 2021 to actually predict the next 10 years, maybe 2030, some of the figures that we might be expecting with certain things. Okay, so these were the things I was thinking about. And I believe you can take it up as some inspiration to actually build some of these things. So that was it. Then we came to the convolutional neural network, which is currently where we are now with regards to the things that we are doing. Unfortunately, we have pending a number of models that we are supposed to build. For instance, the recurrent neural network and the long short memory network. That's all within the recurrent neural network. And then for the recurrent neural network for the language modeling, that's the natural language processing. I'll try and find the resources and also the video we recorded last year, so that at least, even though we might not be able to engage you, if sorry, let me use the word if we might not be able to engage you in the future, you may at least have those videos we recorded last year to also guide you with what we did with these topics, okay, for the natural language processing, where you can actually make some predictions based on some natural language like English. Okay, so last year, the model that we built, we picked some data from I think it was from a news agency. Okay, so with the news agency, what they usually do is they have, for instance, maybe categories of news items. Okay, so there's news items on sports, there's news items on entertainment, there's news items on, let's say, business and stuff like that. So we're looking at giving the headline or giving some text. Okay, what kind of news category, okay, is this news going to belong to? Is it going to be for entertainment? Is it going to be for sports? So we actually did that, and we tested with different examples. And one of the examples I remember using very well, because of my bias towards Arsenal, was Arsenal is going to win the league. And we almost did. And the model was able to predict that there's a sports news. So those were the things we dealt with. Like I said, I'll look for the video, and if I do find it, I'll definitely share it with you, so that at least if we are not able to engage you subsequently, at least you have that resource to guide you. And if there are any questions, you can share them on the page for us to discuss. So clearly, you could see that there were quite a few things, okay? But I believe what we've covered so far has laid a very good foundation, and it is this foundation that is going to propel you, because everything else that we're going to do were based on these neurons and how these calculations are done and how we pick up the matrices and the how do you call it? Um, yeah, how we put in the parameters, okay, the parameters to build these models. So what I'm going to do today is we are going to take a step back and look at what we were dealing with the last time. And let me see. Okay. So we are going to build something. Let me just call this website dot py. And I was testing what I built not too long ago. So let me just close that one up. Okay. Let me just open a new terminal. Okay, so we are going to build that, or we are going to complete, let me put it that way. We are going to complete that application we decided to build the last time, where we already have the model developed, okay, for the gender classification. So whatever thing we built using that gender classification model, let me see if I can find that one. Okay, this is here. So like I was saying, the gender classification model is built, and then we have this saved as model 1.h5 and then model 2.h5. You would also bear with me that we had some few challenges, especially with the performance, okay, when we were trying to test with some of the images, and then we were getting some funny results. For instance, some females were being predicted as males and some males were being predicted as females. Those are the ones, although for those ones, it is a problem with the model and not necessarily the web application. The web application is just a servant, okay, or a medium we are just using to communicate these findings that we have. But you see, the real thing we are trying to do from this is most of the applications we interact, okay, that has some kind of AI engine running behind the scene. We don't see these codes, okay, and we are not going to even understand the numbers behind the scene. Imagine you go to ChatGPT and you type something and everything showing up in some 1100 and stuff like that. So that's not going to make sense. But our understanding of what we did is telling us that, for instance, when we come down here and we do a prediction, and for instance, with what we see over here, we are able to do an analysis and say that, okay, for this particular model, which is the first model, okay, we are going to analyze this, and based on when we are building it, we'll go back and see that this model, okay, we use the sigmoid activation function, and then we had just one neuron at the output. So with the sigmoid, we are saying that, okay, we can determine that threshold, that maybe anything below a 0.5 is a certain class, and anything above a 0.5 is another class, because it is just going to give us one output to think about. So, like I said, if this is a model you have developed and somebody puts in the image and sees this number, it is not really going to make sense. It is not really going to make sense. Okay. We saw that in the second instance of the second model, which is the model 2 that we built, we realized that we used two neurons at the output layer. And then over here, we use a softmax. So we're expecting at least some percentage distribution for male and some percentage distribution for female. And for which reason, you could see that this one, when we did a prediction of the political image, remember the political image is that of Eslowusu, okay? So when we did a prediction of the political image, we saw that we're getting an 83 over here, which basically tells us that, and if you remember very well, the 0 was for female and the 1 was for male. So this is not just telling us that, oh, this is female, but it's giving us some extra information that it is about 83% sure that the image we have saved as political is female, and a very insignificant percentage, about 17%, that it is a male. So the issue I was bringing up was, okay, if this is for instance, this one, okay, the second one we brought up over here, that was with the image we called final image. So with the final image, let me see. I think that was my image, the one I used. Okay, this is a final image. So the actual image is my picture, okay? And as much as it was able to predict that with the final image, you can see that it is about 60, almost 66% sure that this is, or this belongs to class 1, which is the male class. But it is also giving us something to think about over here. So for instance, if this is some cancer diagnostic system and we are predicting that the person has cancer, but then there's about 30% or 34% chance that the person might not have cancer, then we'll probably want to have a second opinion, maybe have a different scan to do a proper diagnosis before we do some chemotherapy or anything that maybe, I mean, that has some harmful effects one way or the other. Okay. So these were the things that we're trying to analyze. But then, like I said, the person, the medic, okay, or any other person who is not exposed to some of these numbers will look at this and ask you, I was expecting the image to be classified whether male or female. What are these numbers trying to communicate? And this is what we use our knowledge of computer programming to write some logic behind the scene to do that interpretation for us. So having said that, we'll come back here and then we'll start writing the code. These models already are here, so we are just going to work with them right away. So I'm going to say import Streamlit as st. Then I'm going to say import NumPy as np. Then I'm going to import TensorFlow as tf. Then I would also want to import okay, I'll say from Pale. Remember, this is a Python image library, okay? I'd want to import, there's a class over there called image. I think these are the ones we will need for now. If there are any ones that will come the way, we'll deal with them. Okay, so what I want to do right away is to start running this. So I can just do Streamlit run, and then the name of the application is website dot py. So I'll run this, and this is going to run in a local server. So basically, this is what we have. Okay, we haven't done anything too extraordinary to our website yet. So I'll proceed to get some text. So since we have imported Streamlit as st, we can manipulate things over here and do, for instance, if I'm to do the title, this we saw the last time, and I'll pass in some text over here. So I'll say CNN gender classifier, something like this. So it is going to be like some kind of a title for the website. Okay, so CNN gender classifier. And then we want that simple text to do some few things. So what I want next is okay, let's try and upload the model over here, which we are going to get from TensorFlow. So let me come back here, and I'm going to say the model is going to be equal to tensorflow.keras.models.load underscore model. We saw this the last time, and the name of the model we have is model 1.h5. I believe you probably might have saved your model in a different name or something, but this is what I've done over here based on the ones that we saved. Okay, so for instance, when I came down here, this one, where did we even save it? Model 1, model 1, model 1. Let me just do a quick search of page 5. Um, good. So these were the places we saved them. So model dot saved, and then we gave it a name model 1.h5, and then for the model 2 dot save, we gave it a name of model 2.h5. So these were saved, and I just these files were what I just picked and then put it in this folder over here. So that's what we have imported over here. So we can literally do something like model.predict. Okay, this object model we have over here, and then pass in the image, and then we are good to go. But before we get that image or that particular image, we need to write the code for it. So I'm going to say image file, something we did last week, and then we are going to call the streamlit.file uploader. So file uploader is going to give us the opportunity. So we have to pass in a string label, and over here I'm just going to say upload image, and then right away let's just give it some restrictions. Okay, so the type of files that we want uploaded, because this file uploader can upload PDF, can upload videos and other things. Okay, so when we put in a type over here, we are kind of restricting the type of images based on the type of files based on the extension we put up over here. So I can say PNG, JPG, and then the last one we would want is JPEG this way. So these ones are the ones that we are limiting, okay, in terms of the images. All right. Now, the next thing we want is so right away, we can actually do a preview of this because I always want us to see exactly what we have. So that's what we see over here. We can drag the file over here, or we can just browse and then pick up the image. So for instance, I can pick up this image, and then that image is showing up over here. But what we also did was to actually do a preview of the image so that we see that, okay, it is indeed this image that we are trying to check for some classification. So what we are going to do is we are going to write just a little bit more code to do the preview. So I'm going to say if the image file is not none, if it is, I mean, something is actually selected, then what I want to do is I want to have an object called image, and then I'm going to do st.image, and then I'm going to pass the file image I have over here. So we are saying that if the file image is not none, that means if something is actually selected, then I want to have that image previewed. So when I save this and come back here, currently there's no file image selected, so technically it is none. But then as soon as I select one, like this image we have over here, it is not none now, so we get a preview of this. Okay, and what we also agreed on was the fact that we can actually make things look a little bit much better, in the sense that we'd want to use the column width. Okay, so we set that parameter to true, and when we do so, what basically happens is we make sure that the entire column width, the image is a little much bigger. Okay, so when I do this, we are good. So this is the image we have selected, and this is what we want to work with. So the next thing for us to do is to have that prediction button over here, and then when we click the predicted button, this is what we want to do basically. So let me quickly do that over here, and I'm going to say something like if st dot button, and then we pass the button predict. If that's the case, or if that predicted button is clicked, basically st And let me just do something small to test this to see. So I'm going to say predict button clicked. So I'll do a refresh of this, and we have the predict button. But then let's see if I come in here and then select this, come in here, the image is previewed. If I click on this, I'm expecting to see predict button clicked. So I'll click on this, and then that's what I have over here, predict button clicked. Okay, so now everything is set and done. So we just have to bring in the image and then do some few things with it to get it work. Excuse me, please, my battery is running down. Let me just plug in my charger. Okay, so I'm back. So this is what we have so far. Now, what we want to do is now focus on, now that we have the image, okay, we probably would want to do some feeding, because what is actually left for us to do is now to do model, which we have imported from this model as we have over here, okay. What is left for us to do is to do model or predict and then pass in the image over here. But that image kind of needs to be processed one way or the other. Because if you recall, when we are testing even with the ones that we have over here, let's go back to, for instance, the first image I have, which is my image, okay. When we brought in the image, this time around, when we loaded the image over here this way, we did a preview, and then remember we had to resize this to a target size. And for those of you who are not with us that time, let me just go back to explain the reason why we have this target size, because we are building a neural network model and we needed to put things in shape, okay. Now we had to specify an input shape, and then we decided to use some image shape, which you could see that I have dataset.image shape, which is what I have over here. So it is a 200 by 200 by 3. This is basically the color channel. And where we are getting this 200 by 200, it is also based on the fact that when we're importing the images we use for training, we specify the target size over here. And this is what has informed us to go with the 200 by 200. So it is important that if the structure for which the model was built use an image size or an image shape of 200 by 200, it is also important that any image we use for prediction in the future should also conform to that image size. However, once again, the user is not going to have that technical background to know that, okay, I'm even expected to put in an image of a particular image shape. So the user, we cannot really compel the user to bring in an image of that particular size. So we have to make sure that we do the resizing behind the scene even before that image is sent for prediction. So what we then do is, okay, then we need to do that resizing. So, and not just the resizing, but then let's say we start with image, okay? So this is going to be that image we have imported and have in here as this image, okay? This image. And then we would want to do some conversion. We would want to do some conversion, but before we even do the conversion, let me see what. Okay, so this is that image we have over here. Now, what I want to do is, and I think that's the problem we had the last time, because based on the structure we built out over here, the images we're using for the prediction, we're actually sending those images by the image name. So they were being picked up by the image name. However, in the building of this model, we are actually sending the actual image and not just the image name. Okay, so it is the actual image. So some things needs to be done so that we get this strange pass through. And that's what we struggled with a little bit the last time. So that's the reason why I have this image imported out over here, because this is what is going to help us do what we need to do. Okay. So what then we have to do is I'll come in and say image is going to be equal to the big image we have over here from the Python image library dot open. So you could see that this one, it says that it's going to give us a string, okay, of the file path or the object. And that's exactly what we want, so that it is almost going to behave like what we have done over here for that particular image we are bringing in. So what we need then here is this image file that we have uploaded in here. So from now, this is going to take care of converting whatever thing we have over here into some strange value, and then the rest of it is going to be okay. So now let me save this, and now let's do a preview of our website to actually test what we have done so far. And it says image is not defined. Okay, image is equal to image. Okay. So I think at this point, let me just clear this and save this over here. So now let's do a refresh. Okay, everything, image is not defined on line 15. On line 15. Oh, okay. So these ones were just okay. So we don't have any problem over here. Let me bring this up. Select this one, and then everything looks good. Okay, we haven't done anything to make this even work, so we are good. So now let's come back here. So what we actually need is the image that we have imported. We want to do some pre-processing. So I'm going to say image dots, and then there's a convert method over here. We want to convert this into RGB. We are just doing this for instances where maybe there are some black and white and stuff like that. We just want to have some kind of a colored version of that image. Okay, the RGB is basically going to give the red, green, blue pixel differences for us. Then the next thing we do is we do image is equal to then image dots. We do a resize over here, and then for the resize we have a 200 by 200. So this is very important for us, so that the image we are using to make a prediction will actually fit into the model that we have developed. So now that we have this out of the way, we can also proceed to do image is then going to be equal to NP. We have NP already. That's a NumPy array. And then we convert this image into a NumPy, into a NumPy array. And then what we can actually do right away over here is to also scale it down to 255, okay? Because this is also something we dealt with when we're building the model. Yes, you see, we rescaled things over here down to by 255, so that the images are scaled down. So eventually we did same over here when we're using it for the testing, okay, so that all the things that were 255 will now become one, and then the others are going to be some decimal values that we are going to work with. So with that out of the way, now we can do the resizing, okay? Sorry, not the resizing, but then the dimensionality expansion. So I'm going to say the image is going to be equal to np dot, we are going to do expand dimension. This is also something we did in here. So this was to the array, okay? And we divide it. That's almost the same thing that we are doing over here. This is to array, and then we divide it. And then the next thing we do is to expand the dimension. So we do np dot expand, okay, dimension, and then we pass in that image, and then we set an axis of 0. So that's certainly what we want to do over here. So we do this, and then we pass in the image, and then we set an axis of 0 over here. So now that we have this, the image is ready to work. So now that we have this image, now we can do model.predict, and then we pass in the image over here. And let's save this as prediction is going to be equal to. Now let's do a preview of prediction so that we get a sense of what we are going to see. So let's do st.write and then pass in that's prediction that we are going to have. So now let's have a preview and see how things will go. We are having an issue over here. It says image is not defined, still on line 5. Okay, sorry, line 15. So let's see what we have on line 15. This image. Okay, let me see. So image was going to be this. So this image is under this if block. And okay, so let me just push this or indent this under this and see. And then if that's the case, this one too has to go. But then let's see if we get rid of that problem. Okay, so we don't seem to have a problem now. Let's see if this one will yield some results. So we bring the image over here. We don't have any problem, but then let's do a prediction. So when I click on predict, what is happening? Okay, good. So we get some value over here, okay? And you remember, these are the kind of values we get. So for instance, when we do, remember this model that we are working with is, which model is this one? This one is model 1, okay? So with model 1, let me see model 1. This is model. So let's see how we saved model.saved. And the name we gave it. So model.saved. Okay, so and this one was model 2. So I believe the model is the model 1. So model.saved is model 1, okay? And then model 2.saved is model 2. So this is model 1. And remember with model 1, we only had one neuron. Okay, one neuron. Where is this one? We had one neuron at the output, okay, and we're using a sigmoid. And currently, based on this prediction, we are getting a 0.0202. So clearly, users using this application are not going to understand what we see over here, okay? And this is where we know that, okay, if this is a sigmoid that we used, okay, we only are going to get one value between 0 and 1. And at least we set a threshold based on whichever parameters that we want, okay? And we are saying that, okay, anything below a 0.5 is going to belong to the female class, and anything above a 0.5 is going to belong to the male class. So that's some logic we need to write over here. So over here, we can come down here and get a little bit busy over here. So I'm going to say we can have a variable called gender. And with this one, I can be a little bit straightforward over here. So I can say it is going to be a male if the prediction, and then over here, we do some slicing over here. Now, it is rather unfortunate that when we do the printing out over here, okay, and with what we see, we are not truly getting, let me just show you this. So let me comment this one out and then bring the data type of what we see over here. So let's do the prediction once again. And I just want to show you something, because at least the one we have over here is giving us something better. Okay, something better in the sense that we actually see kind of the prediction and some sort of the data type one way or the, because this is a NumPy array. Okay, and you can see that we have two angle brackets over here. Sorry, not angle bracket, but then two square brackets over here. Okay, so this one is going to help us. But then what I've done is I just want to see the data type of that prediction that we are getting over here from model.predict. Okay, that's essentially what we have with model.predict, and then we pass in the image, and this is some value that we get. So what I want is that value. So now let me just upload sorry, not the video, but then the image, and then do some prediction over here, do predict, and then we get same value. Okay, nothing has changed, but then we get to see that there's an NumPy array like we saw, and then it has some few parameters, and this one is giving us a lot more attributes and a lot of things over here. Okay, so what we actually need in terms of our understanding that is actually going to come from what we see over here, because it's the same thing, okay, from that same model. But then if we actually want this particular value, okay, then we need to do some slicing, okay, because the first square bracket is going to take one slice, and then the second one too is also going to take another slice. If you understand what I'm saying, this is what I mean. Let me get rid of the prediction, and then let me, for instance, do a slicing of 0. Okay, this is the first thing I want to show, and then we'll do another slicing to actually get the real value. So let me do a refresh of this and use that same image to get to the point I'm trying to make. So I'll get this one, and then when I do predict, yes, we are going to see the predicted value, and also this one is also giving us, it is almost the same, but then technically they are not. Okay, so let me show you exactly what I mean. Now let me also duplicate this and also get another slice out of this. So we are expecting to see 3 values, and I believe each and every one is going to be a little bit different one way or the other. So let me select this one and then do predict. So you see that now with this is the last one. Okay, the last one is what is actually giving us the actual value. I don't know why the others are not showing up, but then they will come. Good. So this is the first one from predict without any slice, and then there's the second one with just one slice. And then when we do 2 slices over here, we get the actual, it is this actual value that we want, because this is actually an integer. Okay, so for instance, if I'm to do checking a data type on this, the last one, we are going to see that it's going to give us something better. So I'll run this, and then once again get this, and then clearly we see that this of a type, okay, not an integer but then a float. Okay, clearly this is a float because it was a 0.00 something. So these are numbers that we can deal with, and clearly you can see that it is telling us that for a float we have these how do you call it, methods that we can apply on floats. Okay, so this one is pretty much okay. So it is that value that we want. Okay, so I'm going to say that I'm going to say if so we are saying that it is male if the prediction, okay, we slice first one, we slice second one, okay, if that value is greater than or equal to, let's say, a 0.5, it is male. Else then we are saying that it is going to be a female. So this is what we want in terms of the logic, okay? It is male. If that's prediction that will be predicted, we slice it and get the actual value. If the actual value is greater than or equal to 0.5, then it is a male, else it is a female. So what I can do is I can do st dots, for instance, right, and in here I'm going to use a formatted string, okay? So I'm going to say predicted gender, and then I'll bring in this, and then I'll pass in the variable gender over here. So this one looks, I think, good for me. So now let's run this for the last time and see what we get. So I'll select the image and then bring it down here. Now, when I press on the predict button, it tells me the predicted gender is female. So this one is making sense. All right. Now let's see. Like I said, we had some issues with the model because we ran it over and over again, and then later on, it just went haywire with some of the predictions. But then let's see, and let's actually also do this so that we have a sense of the values we are getting, okay? Just for analysis purposes. And for this one, let me just do st dot another right, and this time around, I just want to get a prediction value, but then I just want to get the actual value just like that. Okay. So let's come back here. And then let's still work with this one. Okay, for starters. So we do a prediction, and then we are getting the predicted gender is female because look, this is 0.00. It is way within the threshold of female because this is very low. Okay, I mean very zero for that matter. Now let's look at another instance of an image. Okay, so let's take this one for instance, and then we are expecting a male based on what we see over here. And like I said, the model is not looking so good in terms of the value it gives us. Okay, this one too is way low. Let's try another one and see with what we get. And let's try with the males because I think for the females, it is not having too much problems, but then the males, okay, so you see that this one is a female though, but you could see that it is getting a little bit closer, okay, at least to the 0.5 threshold that we are setting for anything above that to be males, okay. So even though it is wrong, but at least it is giving us some indication that yes, it is wrong, but it is not like, of course, wrong is wrong, so we cannot even justify this, except that this one too is still giving us a female. Okay, so let me at this point, let me just try and run this for another time and see. Okay, maybe in the next few minutes. I should have done this whilst we're building the application so that we wouldn't have wasted time over here. But I just want to have a model that is credible enough to make good predictions. So once this is done, it's very simple. We are just going to copy it, okay, the models over here, and just replace that with the ones that we have. And I'll urge and also encourage you to also build your own models and do this deployment and see what you get, okay? So let's just wait for, the first model is almost done. This is a 50 epoch out of 10, and it is getting better by every epoch in terms of the accuracy. Okay, that's dropped. And then we get, okay, so we have a 94% with the final epoch over here. Okay, that's not bad. So this is going to be for the first model. That's eventually going to save us model 1. So we have model 1. So this one is being tested, and then everything said and done, it is giving us this for that, and it is giving us a mil, okay, because this is above the 0.5 threshold that we have set. All right, then for this one, the political image for this one, political is also giving us a 0.9. Wow, this is very interesting, but then this is not what we were expecting. Okay, so that's the first one. Now the second model also comes in, and this one too, okay, this one gives us 100% in terms of it training accuracy. And okay, so this one was model 2. So for model 2 dot predict for this image, okay, so this one is giving us so you see this one is 100% sure this is a female, because this is a first class, and this is to the power -10. So this is very insignificant, okay, in terms of its numerical value. All right, so I think I like the model 2. So now let's try and do a deployment of this model 2. Now remember, this will be saved inside of this folder, so I can just, for instance, do a Control-C of this and then do a replacement. So now if I come in here, it is asking me, do I want to replace? Yes, I want to replace. So the model 2 has been replaced, okay? So now let's do a deployment using model 2 and see how this one goes. We just have to change a little bit of the code. So the model 2 is what we have over here. And over here, this logic is not going to work, okay? Because this logic is just looking at one particular, how do you call it? One particular neuron, and based on the value that is predicted, we are setting a threshold. In the case of model 2, and as we can clearly see over here, we are not dealing with just one neuron at the output layer. We are dealing with 2 neurons. So 2 values are going to come out. But then we are looking at the highest value based on this 2. Now remember, in the past, okay, we used to do np.argmax, okay, and that argmax was giving us either a 0 or a 1 based on the highest value of whatever that we have. And that's exactly what we are going to do over here, because if I'm to do, for instance, np.argmax, okay, over here, I'm just going to see a 0. So when I run this, you see that I'm having a 0 over here. So that's the argmax we are going to use in that kind of logic that we are going to write. So over here, I'm saying that the gender is going to be equal to male if np.argmax. So if np.argmax, okay, of the prediction, and we don't pass in these ones over here, of that predicted value, if it is equal to 1.0, then it is going to be, is it 1 or 1.0? Okay, if it is 0, then it is a female, as we are seeing over here, else everything is definitely going to be a male. Then we put a gender over here, and then we'd want to do np dot this time around, let's get the values over here. So we have done the deployment of the second model. Let's see how this one will also turn out. So let me do a refresh over here and then bring in the same values the same images we are trying to do some predictions of. So now I bring this one. The first one was giving us a very good female. This one too, let's see. So I run this and then I'm getting a female, okay? But then clearly you can see that with the values I have over here, it says that the 0 class is the 1 over here, and then the 1 class is 0. So definitely it's predicted a female over here. So, but then like I said, if you show just this to somebody who's not technically inclined, it's going to be very difficult to make sense out of whatever thing you are saying. Now let's see for the other male images and see if this one is going to help us predict if this gentleman or this image we have over here is a male. So I'll run this, and then over here you see that it is a little bit sketchy over here. Okay, we are saying that, or it is telling us that this is female, but unfortunately we're also getting some probability distribution, sorry, or some values over here. So in terms of Argmax, okay, the maximum, or the in terms of Argmax is a female based on what we see over here. But then this one tells us that